So today workshop, that is the fourth one, and it covers the remaining tests related to the t-test and the MANOVA and the regression analysis. In today workshop, we cover the independent sample t-test and the pair t-test and the MANOVA. MANOVA means the multiple ANOVA basically, and then the next is the regression, both the linear and the multiple regression, and then we go to the interpretation of also how we run in the SPSS. And related to the third workshop, that you can also go check on our YouTube channel, that we cover in our third workshop the simple t-test, one-way ANOVA, post-hoc, and how we interpret these results. It's all present on the YouTube channel. So basically the first analysis, that is the independent sample t-test. You can see here, basically this test compare the mean between the two independent groups. The example is that the stress level of male and female. So the our variable is stress, that is our DV. So we are checking the stress level between the two independent groups like male and female. So how we get this, we move to go to the SPSS interface, that is the analyze, and goes to the compare mean, and then click on the independent sample test. So the pair sample test, this is the third basically the test of the t-test series that compare the means from the same group at the two points, at the two different points. Basically here we can say that the pre and post test, or we can say that this is for the studies that include the intervention and the control group. We measure the stress level of a participant before the intervention and then after the intervention. In this way we compare them and get the pair sample t-test analysis. And how we do it, you can see here is the SPSS dialog box. We just click on the analyze and then click on the compare means. You see multiple options there, and one is the one sample t-test we already covered in our previous workshops, and second is the independent sample t-test, and third one is the we don't need to explain it, and the fourth, that is the pair sample t-test. So our today topic is the independent sample t-test, where the samples are independently from each other. Like in case of gender, the male and female, we are checking the basically the stress level of males and females, and in pair sample t-test we're checking the stress level from the pre or post, basically from time to time. In simple, we can say that if we need a person to check their vitals, including the stress, depression, and all of these things in psychological language, I must say these are the vitals. So emotions or the thoughts too. So we check at the morning or at the evening, or we check for 1 month, and after second month we compare and get the differences. So basically t-test represent the mean differences. So we go to the SPSS, and I have a data set. I run all the analysis one by one on the SPSS too. So we don't need to go in depth here. We run it on the SPSS by practically. So and the next hour basically the analysis, that is the MANOVA. MANOVA basically is the multivariant ANOVA. In ANOVA, to study that we have one DV and the one IV. So we check the analysis variance, but in multi-ANOVA, that is the MANOVA, multivariant ANOVA, that is also called the MANOVA, we have multiple DVs and also single or the multiple IVs. You can see in the example the effect of therapy type on the anxiety and depression level. Basically, we are considering the different type of therapies, like the psychotherapy, like the CBT, like the and other therapies too, to treat the patient with anxiety and depression levels. So in this way, we have number of DVs and number of IVs. So basically, we do the multivariant ANOVA to control the type 1 error. Basically, there are two type of error, type 1 error and the type 2 error. These are error related to the hypothesis that we study the research methodology in a descriptive way. Then we see that what is the purpose, what is mean by type 1 error and type 2 error. Basically, in type 1 error, we accept the false positive or false negative. I think that I will let confirm it with the ChatGPT or the Google. And the second thing is examine the interaction of DV. So basically, here are the two things that we get from the MANOVA. So basically, these are the benefit that we do with MANOVA. If we have the multiple DVs and multiple IVs, we do the MANOVA. So these are the simple steps that we run in the SPSS. One is that go to the analyze again and general linear models, and also run the multivariant. So after we run the multivariant, we go to the output file of the SPSS. In the output file, we see the box M test, multivariant test, where is the pillar trace and the Wilks lambda, and between subject effects. So here we are using the DV and IVs. So the next, so in this way, we cover the t-test. Basically, there are three types of t-test: one sample t-test, independent sample t-test. We understand what is the independent sample t-test. Then we move to the pair sample t-test, and after that, I am combining both the workshop third and fourth. So basically, in then we move to the ANOVA. So in ANOVA, we study the one-way ANOVA, where we have one DV, one IV, and the multivariant ANOVA, or we can say that MANOVA, we have the multiple DVs and multiple IVs. Now, the third one is the regression. Basically, regression is used to check the predictor in our variable. Basically, regression predict the value of dependent variable based on the one. If we have the one variable, that it will be a linear regression. If we have more independent variable, then it becomes the multiple regression. Basically, regression is used, for example, as we see in our example, predicting the exam score based on the study hour. For example, I must say that 6 hours is enough to get the desired exam score. So we check to see whether it's my prediction is good or it's correct or wrong. So it's basically the prediction cross-checking, the whether our prediction or our hypotheses are mentioning about the prediction is correct. Then we run the regression. If we have one variable, that is the linear regression. If we have multiple, then it has the multiple regression. So in regression, we cover only two main in output, we see the coefficient value and R square value, explain variance. So basically, these are the values that we need to interpret for our result in the APS7 kind of APS7 format. So here's the pathway, analyze, and then regression, and then new dialog box, and then click on the linear. When we click on the linear, we select the dependent variable and add the independent variables, and then we get the results here. We see in the model summary, we see the R square, then the degree of difference, and also we see the variables beta value and the standard error and the beta square standardized coefficient value. So and we see the significance value, whether our result is significant or not. So we get this value, interpret our result into the APS7 format. You see how we make in the table, and also the interpretation. So this is the just simple interpretation that we see in the basically did according to the APS7 format. So okay, so let's move toward the SPSS. So we run practically that we are explained right now. Let me share my SPSS screen with you. Let me open the is the data set for the workshop 4, and this is the dummy data, and I generated from the ChatGPT. Okay, so here is the variable view. As we already study how we make the variable view in our first workshop, how to compute the variables and how to make the variable. So the first one is the ID of participant, and I give it the mere nominal. Why give the nominal? Because I just give it the name. The other not it has nothing anything else. Then the gender. In gender, there are the two. I give the label, one to the male, two to female. So our data understand that when we put one, that is male. When we put two, it's female. Then the male is nominal for again for the age, and then for the screen time. And then the group. Here you can see that basically when we study the differences between the t-test and also the other pre or post test, or we can say that for the intervention study, we have two groups. One is the control group, another is the intervention. In control group, we give the participant the placebo effect. In the intervention group, we give the participant basically the doses or what we therapy we are doing. So we give the two code to the intervention group. So our data understand. Then I give it the ordinal. So, no, it's this also the okay, I said no. And the other like it the screen time. Screen time hours, sleep hours, physical activity hours, stress score, depression score, and anxiety score. Basically, the first three are our IVs, and the third, and the second, please mute your. Okay. So basically, the first three are the IVs, the screen time, sleep hours, and the physical activity. It directly relate to our DVs, that is the stress score, depression, and anxiety. So let's move to the analysis part. First, we check the descriptives. So here are the two things. The variables that are in the scale mirrors, we get their descriptives in mean and standard deviation, and the variables who are in nominal and ordinal mirror, we get their frequency. So I click on the frequency and then display the variables names. I just need the age and the gender and the group. So basically, then click on the statistics, and here I need the mean, minimum, and the standard deviation and the maximum. Continue and create the API tables. When I click on it, you can see we get the statistics table. Here are the statistics table, the age of the participant, gender, and experiment group. For the age, you can see the we didn't define the variables for the age, so it give us the lengthy frequency table. So that's why we need only the mean and standard deviation for it. So we delete this. And then second is the frequency table for the gender and the experiment. For gender, we can male are the 44, so that make the 44% of our data set. That and the female, that is the 56. It make the 56%. And then is the experiment group, that is 53% in control group and the 47 in the experiment group. So in this way, we got our descriptive. Second analysis that we go, that is the correlation. We are going to check the correlation with our variables. So basically, this is that's it, as I just opened the SPSS. So we review all the things one by again for all the workshop that we cover. So we move to the bivariant. I click on it, and basically these are our IVs. Three are the IVs, and the next three are the DVs. We are checking the correlation between our IV and the DV, basically independent and dependent variables. We also put the gender and the group here. And then click on the options, mean and standard deviation. We also get the mean and standard deviation, and then the Pearson and the Spearman both. For basically correlation coefficient, the Pearson is used for the homogeneous data. But if our data is not homogeneous, we click on the Spearman, then we we get the result for both analysis. And there is the two-tailed significance and the okay, everything's okay. Then we click okay. You can see. So here are the descriptives of our variable. The first three variable IVs and the second three variables are our DVs. Here are the mean and the standard deviation and the total number of parts 100. Then here is the correlation basically. So we got the here you can see that IVs and DV correlation. So basically this is the new function of I think the 30 version that it show the colors. The other versions that are lower like 51, 26, 78 are not showing that kind of things. So I think there is green color, highly positive. And if it's a light green, then it show positive, but it have some descriptions. And the yellow has no linear. And the next is the I think pink color that is negative. That show the none. So basically this is the give us the description. This is the first time I am also seeing that the 30 version of SPSS is showing it. So basically this is our as a correlation. In our correlation, we see that our first variable has this correlation coefficient value with our IV. So with our second IV, so we check for the DV here. Our three number DVs and other two demographic variables, that is gender and the experimental group. We check by scroll down and see the values here. After that, we move to the non-parametric correlation to check whether the values are same or not. We go through it and see yes, the both tests are not significant. Basically, they are not showing any significance here, even not, if we consider non-parametric data and also for the parametric or the significant or the homogeneous data. So here are the correlations. I just do it further so you can understand that we also run the correlation on it. So let me okay, now we move to our main analysis that we study today. So we click on the analyze and go to the compare means. Again, you see that in compare mean we have multiple options, one sample t-test, independent sample t-test. So I click on the independent sample t-test. As we already covered the one sample t-test, I put here our target variable. So basically my target variables here are the stress, depression, anxiety. Basically they are the DVs. I want to check whether what is the basically they are grouping variable is our the control and the intervention group. I am checking here whether the participant who got the placebo drugs or the therapy show any decrease in stress, depression, anxiety or not. So that's why I choose the test variables, the DVs and the grouping variable, the control group, and click on the options. When I click on options, continue, and then okay. You can see first we get the descriptive, that is the mean and standard deviation. After that, we get the independent sample t-test. That here you see the t value and the degree of difference, and then the significance value. None of the variables are significant. And you can see here is the lower and upper confidence interval value. It's not our useful for here. So no need for the effect size. If our results are significant, then we move to the effect size to check how much our variable are basically so that's mean differences. So in this way we did the independent sample t-test. Next we do the paired sample t-test. We move again compare means and the portions and click on the paired sample t-test. Basically you see that here is the new kind of dialog box. For example, we are checking the depression time to time. So here is the depression score will be I can must say that the depression pre-depression score, then is the post-depression score. So for that we go back to the data set. So yes, here is the data set. So you can see that here is the depression score. I need to make it another depression score for, I must say it is for post. I add post here. So this is the post depression score and this is the pre-depression score. I click here the pre-depression score. So also copy the post and the pre. So we understand what we are doing. So that's why we put the labels here. And again, the scale, this will be the scale also. So we move to the data view. You can see that here is our data view. We got the new variables, that is the post-depression score. So here is our pre-depression score. And as we do using the dummy data, so this time I copy the anxiety score and paste in the depression score, post-depression score, because if I copy the pre-depression and paste it in the post-depression score, both will be the same, and we didn't get any kind of differences and the results here. So that's why I am just clicking on the anxiety and Control C, and then I goes back to the post. This is the entry one. I click here. You can see I goes there and make this decimal 0 and go back here. You can see here we get the pre and the post. Now we run the analysis. We go to the analysis, compare means, and then pair sample t-test. Here is our pre. Okay. And the second is the post. So our variable is a depression. We got the one variable at the post and the other score is the pre and post. So in this way, we got the one variable. So we click on the options and continue, and then standard deviation. Okay, when click okay, we can see that we got the pair sample statistics that is showed at the mean. In the pre-depression score, we have the number of participants 100, and the post we have the number of participants 100. So then we see pair 1 that is showing the pre and post and its correlation, and then it's the significance value, and the one side is 0.5 and other. Then we move to the pair sample results. You see here we got the mean, standard deviation, and the t and the degree of freedom and the significance. You see here that our two-sided significance level is 0.001, so it is significant. It means our participant showing the depression score lower in the post condition. It means our therapy or the placebo drugs that we're using on our participants showing some results in control and intervention groups. So here are the pair sample t-test, and then we do the MANOVA. We go to the general linear model. So basically, if we need the one-way ANOVA, we go to the compare mean and portion and click one-way ANOVA. But if we do the multiple ANOVA, then we click on the general linear model, not the generalized linear model. We do the general linear model and click on the multivariant. When I click on the multivariant, this dialog box is open. You see here is the multivariant. I put my DVs there. You can see here are my DVs. That is the stress score and then the anxiety score. Now I add the post score here because our current score will be the post, not the pre one. Okay, I put the pre because we copy the anxiety to the depression scores. That's why it didn't work here. So here is the anxiety, stress, anxiety, and depression in the dependent variables. Now we put the fixed variables here. So we want to check against the group, basically the control and intervention group, and also check against the gender. So here they are our control group, and I put the DV, that is the screen time, and also as a covariant. I click on it and drag the three variables that are our IV act as a covariant. Then I click on the model, that is the total factorial model. Okay, and the contrast, no need, and then the plots, no need, and the options here. We get the descriptive statistics, estimated effect size, and the homogeneity test. So basically, these are three tabs we need to click, and then click OK, and then click OK here, and we got the results. So basically, in general linear model, as we study on the slides, we got the between subjects factors. So you can see that in experiment group, we have the control group and the intervention group. That is here is the size, sample size, and then in the gender we have these. After that, we got the descriptive statistics for it, and then we move back here. We get the box M, as we already studied in the slide that we get the box M test. So here we see that our significance, the overall the analysis is not significant because the value is 0.09. If point is lower than 0.05, then is our analysis significant. Degree of freedom is for one group is 18, for other is that is, and its F value is 1.457. So let's move to the multivariant test. Here is the intercept. Basically, this is constant. This is for basically showing how the analysis works. And then we move to our first IV, then the second, then the third, and after that we have the group that is our fixed factor, the group basically control interval and gender, and then how they both interact and give us the analysis. So you see here the F value and then the significance value, and then that's all here, and the eta square value too. So you can see in the significance value, none of our variables showing the significance. So we can say that our IVs and DVs, we can say that our group or gender is not predicting on our DV. So this is how the MANOVA work and the run. And after that, we goes to the regression. That is our last analysis that we study. So I click on the analyze and then the regression. When I click on the regression, new dialog box, that is the linear. I click on the linear. Now I put the one DV here. I put here the one DV, that is the depression. I click here. Okay, then I click on the three IVs. If I click one IV, that it will be the linear regression model because one IV, one DV. Or sometimes we add the other the number of IVs increases 2 or 3. But it must be remembered we have only one DV in linear regression, but number of dependent variable increases in our multiple regression model. So I click 3 IVs here and move to the dependent variable. Click on the statistics and then R scale changes. This is a must. And okay, continue, and the plot, no options. Okay, and then I click okay. You can see here is we use the enter method for the regression. So basically our DV is depression and the other is our IV. So you can see in the model summary, we just check the R scale value, that is 0.38. That is basically the variance 38. It will become 38% variance in our data. And then the significance value. So our overall mode is not significant. You can see here the significance value is not less than 0.05. Then we check the ANOVA here, and then because in regression we get the ANOVA value 2, and then the coefficient you can see here is the model 1. If we have multiple DVs, then we have the model 2 and the model 3 according to our number of dependent variables. So in this way, we run all our analysis on the SPSS. So, and for interpretation, you have the slides. Basically, in this way, we cover our 2-day workshop, how we run the analysis in the SPSS, because last time, most of the participants, hopefully they are present too, they said we need the analysis, how to run on the SPSS, like the dependent and the also the multivariant. So hopefully this work. If you have any question, you can ask in the group, because the meeting is about to end in a minute. So I give you share the recording in the group and the YouTube, and hopefully